Okay, here we go on the week 20 test video. So the very first question, multi-step angle measures. We have to find A and B. That question mark gives you an idea of where to start. So we're going to start by identifying the question mark angle, and to get it, we're going to use the idea of vertical angles. So if we look at these two lines intersecting, we know that on the opposite side of the intersection, angles are the same measure. So if this is 50, then this is 50. Secondly, we know that this box right here tells us that there's a right angle, 90 degrees. Since this line has 180 degrees total, everything above that line is 180. In fact, everything below the line is 180. If you'll notice, that makes a full circle. Circles are 360, go figure. So since that whole thing above the line is 90, and this part's already 90, then we know that that's 90 also. So now we've got three angles total in a triangle, and we know that those three total angles, when you do a triangle, let's use this space over here for some notes, a triangle totals 180 degrees. Well, we've got 50 and 90 and A all making 180 degrees. So 50 and 90 and A all added together equal 180 degrees. The 50 and the 90, that's 140. So 140 and A make 180. If we take away that 140, we can see that A is 40 degrees. That spot right there, 40 degrees. For B, well, we know that A and B are supplementary angles, just like these two were supplementary, the two 90s. They total 180. A and B, A plus B, also total 180. They are supplementary. So if we know the A is 40, then we know that B has to be 140. And there's your answer to problem number 1. All right, on to problem number 2. Scale drawing. So on this one, we are going to keep track of this fact right here. Each unit is a total of 3 feet. So what are the actual dimensions? So when they're saying actual dimensions, what they're asking us is, what's the length and width? All right, so for the length, I'm going to use some space. Got a lot of space on this problem down below, so I'm going to use this space down below. So part A. For the length, and we decided that we were going to call this measurement length and this measurement width. If you did it the other way around, that's fine. If you called this across the front length and this width, that's okay. We're going to get an answer that you can, if your label changes slightly, that's all right. It still means you have the idea. So we know that each unit is 3 feet. So how many units are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 units. So I'm doing the width now. For the width, there are 9 units, and each of those units is 3 feet. 27 feet all together. So up here, width was 27 feet. For the length, the way that I'm defining length and width, 1, 2, 3, 4, 5, 6 units. So for the length, 6 units times 3 feet each, 18 feet. So for the length, 18 feet. There's your answer to the first question. All right, second question. You got to redraw that box because it's in part of my second question that I want to highlight for you. Second question. what is the perimeter of the bedroom? So we know perimeter means all four sides. So when I get down here to part B, and I'm finding perimeter, that's the same as saying what's the total of all four sides. So all four sides total. What do all four sides add together? So I've got 1, 2, 3, 4, 5 units. That's 5 units across. So that was my width. So my width is equal to 5 units times 3 feet each. 15 feet for the width. And pick out a different color here. And for the length, 1, 2, 3, 4, 5, 6, 7, 8 units. So for the length, I've got 8 units times 3 feet each. That's 24 feet. Now, to find perimeter, we said it's all four sides total. And a formula that you often see used for perimeter is the formula 2 times the length plus 2 times the width to get the perimeter. 2 lengths, both sides, 2 widths, those 2 sides, get the total. So if I use that formula here, I've got 2 times 24 plus 2 times 15. 2 times 24 is 48. 2 times 15 is 30. I get a total of 78 feet. So the perimeter equals 78 feet. All right, finally, what's the actual area? So when we do area, area is always length times width. So let's do that right down here. We'll do part C. Length times width. And that's area of the living room. And we already, right up there, we already got the 2 parts of the living room. Let me circle my answer here on perimeter just so that stands out for you. We already got the length and the width. We said that the length was 18 and the width was 27. And when you multiply 18 times 27, you get 486, and that's done in square feet. Square feet. So our answer to this is the area equals 486 square feet. That's the other way you can show square feet. You can either write SQ feet, or you can put feet with a little 2 for the exponent. All right, to the back of the test. So on the back section, question number 5. It says, identify each statement as always true, sometimes true, or never true. First statement, vertical angles are congruent. That, my friends, that is an always true. And that's the definition of vertical angles. So you know that based on the definition of vertical angles. If you wanted to show that with a diagram, remember I told you you had to have an explanation for each one. Here we go. This is angle X, this is angle Y. They are vertical angles, and so we know that angle X is congruent. That's a horrible little thing for congruent. Is congruent to angle Y. They're the same size. All right, the sum of the measure of 2 supplementary angles is 90 degrees. That is never true. And the reason why that's never true is supplementary don't total 90, supplementary, total 180. This total of 90 is an example of complementary angles. So complementary angles total 90 degrees. Letter C. If the measure of an angle is represented by x, then its complement is 90 minus x. That's an always true. So we just said in part B that complementary angles total 90 degrees. So if you had an angle that was, say, 50, and you wanted to know its complement, got to go back and fix my spelling right there. I just realized I spelled that with an E instead of an I. There we go. If you had an angle that was 50 degrees and you want its complement is going to be 50 plus what? Let's call it A for angle, equals 90. Well, I guess I should call it x since we're using x in this question. So let's call it x. 50 plus x equals 90. Well, then if 50 plus x equals 90, 90 minus x equals 50. All right, and letter D, complementary angles are always adjacent. That's a sometimes answer. So you can have complementary angles that are adjacent. You know what? I spelled it right the first time. I'm going back. Complementary. Yeah, no. I liked my first spelling better. They made a mistake in their spelling somewhere along the way. All right, so this is sometimes, because complementary angles, they can be adjacent. So let me draw you a pair of adjacent complementary angles. They're going to be two angles that total 90 degrees. They look just like this. Let's say that angle is 35. So if that's 35, and they have to total 90, 90 take away 30 is 60, take away 5 more, this angle has to be 55. So there are two complementary angles that are adjacent. Adjacent meaning they touch each other, they share a side. In the case of these angles right here, they share that side and they share that vertex. However, I could draw those two angles. Without making them adjacent, but they would still be complementary. There's the first one. Here's the second one. And they still total 35 and 55. They still total 90 degrees, so they're still complementary, but they're no longer adjacent. All right. Two-step inequalities. You got to love them. Two-step inequalities. Here we go. Remember, these are the problems where we've said all along, take that dashed line, put it down through. Now, this is one that we're not going to change the direction of the inequality, because this, when we divide by this coefficient, it's not going to be negative. So I know going into it, this is going to be the case. It's going to be x is greater than or equal to something. Let's figure out what that something is. I'm going to take away the 14. Over here, I'm going to think of it as add negative 14. Remember, those are the same thing. Subtracting 14, adding negative 14, they're the same thing. Here, cancel out entirely, which means I'm left with 6x greater than or equal to 28 negatives plus 14 negatives are 42 negatives. Divide by the coefficient on both sides, and you get x is greater than or equal to -7. And that's my final answer, -7. So I'm going to put my -7 on the number line. I'm going to number the rest of it. Remember, negatives, as you go to the right, things get bigger. So -4 is bigger than -5, and -5 is bigger than -7. As you go to the left, things get smaller. This answer was greater than or equal to which means when I circle that, I also fill it in. And I need the numbers that are greater than or equal to -7. So that includes numbers like -6 and -5 and -4, all the way going along. So when I want to check, I'm going to check not with the -7, because if I check with -7, I should get equal to. And the problem with equal to is it doesn't tell me what direction the line goes. So I'm going to check with -6. So I'm going to have 14 plus 6 times -6. Is that greater than or equal to -28? Remember, if it's greater than or equal to, it'll be less negatives. It'll be like a -22 or a -15 or a -10. There'll be fewer negatives. All right, so step 1, get rid of the 14. Oh, excuse me, I'm not getting rid of now. I'm checking. Thanks. My brain took a vacation. So 14 doesn't change. 6 times -6 is -36. 14 positives and 36 negatives, they cancel. They don't combine. They cancel out, leaving 22 negatives. And yes, 22 negatives is a greater amount than 28 negatives. All right, Bob and his vacation. Bob wants to spend at most $100. When you see at most, it means he'll spend less than that, or he'll spend $100, but he won't spend more. He wants to spend less than or equal to. So he wants to spend at most $100. So he wants to spend at most $100. He decides to rent a scooter that costs him $15 per hour. So I'm going to go ahead and use H as the number of hours. Plus he has to pay a $25 maintenance fee. So that's a one-time fee of $25. So here's what Bob knows. Bob knows he's paying $15 for each hour he has it, plus he's paying a $25 one-time maintenance fee. So let's take away the maintenance fee, because again, we're trying to figure out how many hours he can afford. So let's take away the maintenance fee, and that means these two cancel out, and his $15 an hour, he has to do that for less than or equal to $75. Let's divide by the 15 to find out the amount for just 1 hour, just one H. Remember, that makes a big one right there. And so for just one H, 75 divided by 15 is 5. So here's what we know. We know, and I'm going to just gather my work here up a little bit, give us room to graph this. There we go, get it out of the way. Here's what we know. We know that we've got 5 hours, 4 hours, 3 hours, 2 hours, 1 hour, 0 hour, 6 hours. We know that Bob can rent for 5 hours. He can rent for less than 5 hours. Here's what he's not going to do. He's not going to rent for 0 hours. It would make no sense for Bob to rent for 0 hours. Renting for 0 hours would mean Bob walks in and he says, here's the maintenance fee, $25. Oh, but I don't want to rent it. But go ahead and keep my maintenance fee. Bob's not an idiot. Bob's not going to rent for 0 hours. As a word answer, possible number of hours Bob can rent the scooter, at most 5 hours. So it's 5 hours or less. All right, down to the bonus problem. Which expression could not be used to find this? And that's expression B, because you're taking away both the 38 and a negative 90. If you think of this, this is like 180 minus 38 plus 90. When you take away this takeaway, it ends up being addition. So B was the answer that couldn't be true. All right, there you go, folks. You've got your video for week 20. Study that. You're going to see a lot of these problems show up again on this next test, so be prepared.